So in this problem, it says an octagon has 4 pairs of congruent interior angles measured in degrees. The measure of each of the largest pairs is twice the measure of each of the second largest pair. The measure of each of the second largest pair is twice the measure of each of the angles in the third largest. Finally, the measure of the angles in the third largest pair is twice the measure of each of the angles in the fourth largest pair. So we want to determine the degree measure of one of the 2 largest angles. Now this is not to scale at all, but let's say the 2 smallest angles are x. So what are the next 2? Well, they're going to be 2x and 2x because they're twice as big. What's going to be the next pair? They're going to be twice as big as that, so 4x and 4x. And then after that, twice as large again, 8x and 8x. So if we add all these up, now what I'm going to do is I'm going to take a pairing approach. X and x make 2x. 2x and 2x make 4x. 4x and 4x make 8x. 8x and 8x make 16x. So if we add all of these together, 4 and 16 make 20, 8 and 2 make 10. So that means this all adds up to 30x. So this is the sum of all the angles in an octagon. Now, how many degrees are there? Well, we take 180 times n minus 2, where n is the number of sides. So we multiply 180 by 6. So 180 times 6 is 1,080. So if we divide by 30, that's going to give us the value of x, the smallest angle, which is 36. However, that's not what the question asks. The question asks, what is the degree measure of one of the largest angles? So if x is 36, the largest angle is 8x. So that's 36 times 8. And if we take 36 times 8, we get 288 degrees. And there's our answer. And we're done.